Two-port network analysis, calculation of two-port parameters. We have seen the illustrative examples. Now we will see different problems on given from the previous question papers. This also two-port parameters. You have freedom of two things. You can use the old method by keeping I1 0 and I2 0, and you can go for new method. Whether we go for previous old method or new method, you can follow. You just go through as I am teaching you what method I am applying for what purpose. The main goal is to do the problem in less time. Let's go to problem 1. Question number 1, we say, the question says, the H parameters of the circuit shown in figure, GATE2023, 2 marks given EC. So, if you look at this, this is basically what you call L network. And you have two freedoms now. You can calculate the Z parameters and convert into H parameters, or directly go for H parameters. This is all A, B, C, D. Okay. You have these options given to you. Let's go to solution. If you calculate Z parameters using the new method by just KVL and KCL, you'll get 30, 20, 20, 10. From there, determinant is 200 because 600 minus 400 becomes 200. Then convert into H parameters. Actually, to remember this is very difficult. Therefore, you have one option. That option is write the equation V1 is equal to 30 into I1 plus 20 into I2. V2 is equal to 20 into I1 plus 20 into I2. Readjust the equations to suit your H parameters. That is also new method is possible. And therefore, our option is D. Let's go to question number 2. The Z matrix of two-port parameters is given. Z11 is 0.9, Z12 is 0.2, Z21 is 0.2, and Z22 is 0.6. Then calculate Y22. He is indirectly asking for conversion of parameters. That too, this conversion is basically in terms of what you call within the pair. When it is within the pair, you can just say inverse. So, this is also given in GATE 2004, 2 marks given. Please understand, wherever there is a conversion, they are giving more marks. Conversion demands two things. The equations you should remember are, take the equation, adjust into that. As I gave a new title, it's not the conversion, but it is adjustment of equations. So if you adjust into equations for the given equation, you can comfortably do that. So let's see the options and see the problem. Calculate delta Z 0.5. Y22 is Z11 by delta Z, that is 0.9 by 0.5, 1.8. This is going to be very quick because it is within the same pair. Same pair means what? Z is a pair for Y, Y is a pair for Z. This is question number 2, option is D. Then let's go to question number 3. A two-port device is defined as following pair of equations. I1 2V1 plus V2, I2 V1 plus V2. Then the Z parameters are, this is given in GATE and options are here. Answer is very simple. The two equations given to you is giving Y parameters directly. When Y parameters are directly available, you can just calculate Z parameters inverse. So 2, 1, 1, 1 is the Y matrix. Look at here is the Y matrix. From this equation, you can have Y matrix and find the delta there, the determinant here. Then you know Z11 is Y2 by delta Y, Z12 is minus here, Z21 is minus here, Z22 is here. By that, you can comfortably do this conversion. And therefore, option among the options given, B is the option. B is the option given for us. Question number 4. This is definitely a peculiar question, and that's called calculate Z parameters for the network, and that network is called lattice network. I have given this word shown in the figure. ZA, ZA, ZB, ZB. This is a two-port network available. Then what is the solution here? The best thing I am going to go is the old method, because to make a new method is very difficult. In my new method, my idea is simple. How many loops are there? I should know. How many nodes are there? It's almost giving 4 loops, 4 nodes. It's highly impossible. Therefore, I have decided to go with the old method, which says put I2 0, get Z parameters. Put I1 0, get Z parameters. Therefore, if I put I2 0, these two become series, and here also these two are becoming series. See that? If I put I2 0, they have become series, this has become series, and this is the I1. ZB, ZA, ZA, ZB. When these two are parallel but equal, what will happen? The current in two equal impedances are half and half. I1 by 2, I1 by 2. Then please apply the equation here. V1 is equal to I1 by 2 into ZA minus I1 by 2 into ZB is equal to 0. So V1 by I1 is Z11. So you can comfortably say ZA plus ZB by 2. That's what it is. Similarly, if you calculate for V2, you will get this. Therefore, these are the answers available. Z11 is 1 by ZA plus ZB. Z21 is 1 by ZB minus ZA. So with I2 0, I can get 2 parameters. And if you do for the same thing, if you repeat with I1 0, you will get the same answers. Therefore, whatever is Z11 is equal to Z22. Whatever is equal to Z21 is equal to Z12, because circuit is symmetrical. Therefore, I have given the answers here. Look at here finally. Z11, Z22 both are equal. Z12, Z21 are equal. This is the problem I have given. You can see what examiner is asking by substituting these things. So this is what I mean by lattice, how to calculate. I have preferred the old method, parameters by parameters calculated, right? For question number 5, for the lattice network shown in figure, ZA is given as J2 ohms, ZB given as just 2 ohms. Find the Z parameters. This is GATE 2004. Please understand, this is just application of the previous problem. In the previous problem, if you remember, I have just told you, the answers also we remember, ZA minus ZB by 2. That means ZA minus ZB, J2 minus. So when you say Z11, J2 plus J2 by 2 means 1 plus J. So wherever there is 1 plus J, that means rule out B, rule out C. You have to have either C or D. First two things I am ruling out, because if you remember my previous problem, remember these equations. ZA plus ZB by 2. Here ZB minus ZA. Only those two remember. So ZA plus ZB by 2, 1 plus J. ZB minus ZA, that means 1 minus J. So this is correct. Option is D. It is just extension of previous problem. Okay, option is D. Sixth one. For the circuit shown in figure, C is given as 0.025 angle 45. Then calculate Z2. This is GATE 2005 2 marks. Whenever 2 marks is given, that means little complicated. What complication is here? Absolutely there is no complication. The only idea that you need to know is C means what? ABCD parameters. So take ABCD parameters, take the circuit, get the ABCD parameters, equate this value to C, you will get solve for Z2. So please take this Z1 and Z2, calculate C parameters, equate that C parameters with this value. The only unknown you should get is Z2. You can comfortably get the answer. Shall we go ahead? Now look at your transmission line parameters. I1 is CV2 minus DI2, because C is linked with second equation. I am not taking the first equation, I am directly jumping into second equation. Therefore, if I2 is 0, you will get C. I1 by V2 is C. Therefore, get this value. Put I2 0, then all this current is same. So what is the value of V2 here? V2 is equal to just I2 into I1 into this value. So look at here, V2 is I1 this side, I2 this side into Z2. Look at here, that is V2. What is V1? He said 10 angle 30 is C into I1 minus. And what are the equations possible? This is V1 minus 10 angle 30 I1. Then I1 plus I2 into Z2. So I have taken the equation for V1. I have taken the equation for V2. If I put I2 0, what will happen? This is 0. This is 0. So calculate I1 there and substitute here. You can comfortably get the ratio between V2 and V1. So follow me. If I2 is 0, V2 is simply V2 by I1 is equal to Z2. What is Z2 now? 1 by C. And that is 1 by C means that angle is, if you calculate, C value is already given, 1 by 10 angle, and you can comfortably convert that value into this angle. So Z2 will become 10 minus 45. So what exactly I am saying is very simple. Take the circuit, calculate C parameters as if you don't know. Answer will come in terms of Z1, Z2. Z1 is given to you, C is given, the only unknown Z2 you can comfortably calculate. Therefore, the answer among the options given, it is B is the option. Question number 7. For the network shown in figure, calculate Z parameters for the following switch conditions. Please remember the 7th question and 8th question, they are linked problems. In GATE exam, the most interesting and most difficult is linked problems. What's the meaning of linked problem? The answer of the first problem will act as a data for next problem. So follow ABCD here, options given, but more than the option, circuit is very important. Look at the circuit. This is the circuit given 2 port. V1 and V2 are voltmeters. 6 and 1.5 is voltage here. Currents are here. Now let me tell what is the equation, what are the situation here. If switch 1 is open, that means I1 is 0. That automatically current is 0. V1 is 4.5. A2 is means I2. V2 is given. So it is just like measurements in the lab. You measure the values and find out what is the circuit inside or the parameters inside. Now when S1 is closed, S2 is open. That means what? I2 0. Then values are given. Please remember, when I1 is 0 here, what values will come? Z parameters will come. V1 by I2, you will get Z12. Then V2 by I2, Z22 will come. Like that you can get 2 parameters. 2 parameters will come from here. Other 2 parameters will come from here. So instead of you calculate from the circuit, now you are going to calculate the parameters. So if you calculate like this, put I1 0, Z12, Z22. Put I2 0, Z21 is V2 by I1, 1.5. Z11 is also V1 by I1, 1.5. Now if you see the matrix, according to the matrix form, the option given is C. That is 1.5, 4.5, 1.5, 1.5. This is the option given for us. You don't need to substitute I1 0, I2 0. He already substituted or is already using the switching. Now this Z parameters, you have to use it in the next question to achieve. As I told you, this is a linked problem given. This question is, for the network shown in the figure, calculate H parameters for the following switching conditions. You have two options here. You can calculate H parameters directly, or you can calculate Z parameters and come. The old method says calculate Z parameters and convert into H parameters. That is definitely true here, because I1 is, he himself made it 0. I2, he himself made it 0. So when I1 is 0 and I2 is 0, the best possible parameters are Z parameters. From that Z parameters, if you convert into H parameters, you will get the answer. That's why the answer you achieve in the previous problem has become a data for this problem. That's why this is called linked problem. Each question will have 2 marks. In a linked problem, negative marking is there for the first problem, negative marking is not there for second problem. You know why? Because if the negative marking is not there, is not there for second, means because if the first one is wrong, second one is anyway wrong. That's why take the Z parameters you achieved in the previous one and use it here for the sake of conversion. See here, the conversion of H parameters, this is the conversion of H parameters. Actually, instead of you doing like this, you can also say conversion V1 is equal to Z11, V1 is equal to, for example, 1.5 into I1 plus 4.5 into I2, V2 is equal to 1.5 into I1, 1.5 into I2. You make the equations from Z parameters and adjust the equations according to our H parameters. So adjusting is very, very important. So if you don't remember this, the best thing, don't be panicked. You just write the equations of Z parameters, substitute these values. 2 equations can be converted into in any form. That's called adjustment of parameters. So you can always adjust the parameters and then achieve the expected parameters. Now, for the network shown in figure, he is asking for Y parameters. This is basically pi network. In a pi network, how many nodes are there? 2 nodes are there. How many loops are there? 1, 2, 3. Number of loops are more. That's why don't go for mesh analysis. Go for simply what you call nodal analysis. Apply KCL at V1, KCL at V2. You will get 2 equations. Directly you will get H parameters. Come on, let us see there. If you really apply these equations directly, like I have done in the theoretical class, this is minus I1, V1 into YB, V1 minus V2 into YA. So therefore, if you say I1 equation, if you take I1 common, V1, V2 common, you will say YA plus YB is here, minus YB here. This is already we have done. So pi parameter standard equations are already there. Even if you forget, you apply KCL here, adjust the equations and achieve the parameters. So that is how you can calculate Y parameters of a given circuit. Next, question number 10. The parameter type and the matrix are given. We need to find out which matrix is suitable for this equation. It's a very interesting and very small. Look at this one. Output is V2 is 0, I1 is 0. Slowly let us find out what is possible. Let us write what is given here. Output is shorted, input is open. Therefore V2 is 0 because output is shorted. Short circuit means 0 voltage. Open circuit means current. So V2 is 0, I1 is 0. When we go for G parameters, I1 is G11 V1, G12 I2. V2 is G21 V1 plus G22 I2. At I1 0, what will happen? I1 by V1 0, I1 by I2 also 0. Now let me take the second option. V2 is 0. G21 is V2 by V1. V2 by V1. When you say G21, V2 by V1. So when V2 is 0, what will happen? G21 is 0. Then G22 is what? V2 by I2 again. That means 0 by I2. Therefore again 0 by I2 is 0. So all zeros. So now go back to our options. Look at here. G parameters all zeros. Therefore option is C. Introduction to network functions and synthesis. Actually, synthesis is a subject separately available for IES. Whereas for GATE and PSU, a small introduction is required. So we are going to see the different small concepts as an introduction to network functions. Remember, all that we have done so far is analysis. So let me give you some definitions and classifications and calculations. Right? Let's go. First one, definition. Network synthesis is realization of the network for the available input to achieve the expected output. Please remember, if you look at this one, network, if input is known, network is known, that is called analysis. If input is known, network is known, output is calculated, is called analysis. Whereas in synthesis, input is known, output is expected, that is also known, then you calculate the network. So far in network analysis, we have calculated output. Now we are going to calculate network itself. We don't call it as a calculation, we say realization or synthesis or design. So we are finally going to achieve the hardware. You may do 100 times analysis, synthesis you will do the best one. Wherever the analysis is satisfied, you go for hardware. That's called network synthesis. Now let me define what is the network function. Network function is defined as Laplace transform of output by Laplace transform of input with initial condition 0. But remember, this is also called transfer function. Therefore, there is not necessarily this to be a Laplace transform. It can be any transform. Any transform of output by any transform of input with initial conditions 0. It all depends on the type of input is given. For example, if you want to see sinusoidal inputs, the best one is Fourier transform of output by Fourier transform of input. So depending on the inputs you are given, depending on the system you are dealing with, the definition can be any transform. It can be a Z transform by ratio. It can be ratio of Fourier transform. It can be ratio of any transform. That is called generally network function. Why it is called network function? This describes the function of the network in the mathematical form. When you see the network physically, that is called network. When you see the network in mathematically, that is called network function. It will give you the function of the network, right? So let me classify them now. Network functions can be classified as driving point impedance 1, transfer function is another. When I say driving point, same input, you take V1 by I1 driving point, V2 by I2 driving point impedance, then Z12 V1 by I1, V1 by I2, Z21 V2 by I1. These are called transfer functions. Therefore, driving point impedances and transfer functions are there. Now driving point impedance, it is calculated at the same port as I told you. If you do at the same port, it is called driving. If you do at the other one, it is called transfer, because one port to the other port is generally called transfer. Same port, it is called driving. So then transfer function can be defined in so many ways. Suppose voltage by current, transfer impedance, current by voltage, transfer admittance, and it can be transfer impedance, transfer admittance. It can be forward current gain, forward voltage gain, reverse current gain, reverse voltage gain, like that. Depending on the ratio, you can speak and title the name. But remember, a note, I have given a note here, a network function must be primarily positive real function. Positive real function. Okay? So if it is not a positive real function, we cannot even synthesize. Okay. Now let me talk to you about what it means by positive real function and what are the properties for a function to be positive real. Let f of s be the positive real function. Okay. F of s is real for real values of s. The value should be real. That's why it's called positive real function. And all the coefficients must be positive and real. That's why it is called PRF. Actually, in a short form we call PRF. All coefficients must be positive and real, and they are real values of s. Third, f of s must have no poles on right half of s plane, and f of s must have simple poles on geometry axis with positive and real values of residues. It should always have positive values. Okay. If you have the positive value, for example here, s plus 1 is the 0. If s plus 1 is equal to 0, what is s? S equal to minus 1. That should be on the negative side. When in the function, if it is positive, the roots are on the left side. If the function on the positive side, if roots are on the left side, therefore you can comfortably say that it's stable. Then different properties we are seeing. Fifth property, the difference between highest powers should be unity between the fractions. That means look at here, 2 power s power 3, 2 power s plus 2. So that the difference between 3 and 2. So 2s cube plus 4s, 3s squared plus 10. That means the maximum it can have a difference of unity. The difference between the lower values also at the most should be unity. How I mean that? Here is 4s, here is 10. Then what is the difference between this? This is s power 1, this is s power 0. So please remember, highest power is differ by unity, lowest power also differ by unity. These are called properties of PRF function. Every function should be PRF before it is really synthesized. If it is not PRF, don't go for synthesis. It is all waste of time and waste of money. Then note, sum of PRF is also PRF. If f of f is PRF, 1 by f of s also PRF. That means if the impedance function is PRF, admittance function also PRF. That's why Foster form 1 is talking about impedance, Foster form 2 is talking about 1 by impedance. Both are realizable. So any PRF function is realizable. If impedance function is realizable, admittance function also realizable. That means you can have the realizability either in the jet impedance or in the admittance. That's why we have brought a new word called immittance. That is called acronym in English. We say if one part was some words of the one word, another word of another word, if both are combined, we call it as immittance. So immittance is an acronym or a combination of two words, impedance and admittance. So you can have a circuit for impedance, circuit for admittance. Next, network synthesis can be analyzed for dissipative and non-dissipative networks. If a function is given, you have lots of ways of doing. That's why I said one word. The realization or synthesis is not unique. If you go for analysis, whatever the technique we use, answer is 5 amperes means 5 amperes, that's all. For example, you have KVL, KCL, you have mesh nodal, you have cut set and tie set. You do any one of these three, answer will be same. But here, if you take different techniques, the definite answer is not same. Different forms will come. But if you take again the network function for that circuit, you will get the same. Therefore, approaches may be different, the solution may be different, but finally the ZFS that you calculate has to be same. So there are two types of circuits. One is dissipative, other is non-dissipative. Dissipative means resistor, non-dissipative means inductor and capacitor. They don't dissipate, that's why they call poles. So dissipative networks are RL, RC. Non-dissipative is LC. It's totally RL you have, RC you have, LC you have. All are in either series and parallel. They're called Pastel forms. Then Kaur forms. So like that you have 4 forms in each topic. and circuits are 3, LC, RL, RC. In each one 4, total will become 12. If you do 12, you have done the total subject of this network synthesis. That is introduction. Properties of RC network. For RC driving function, impedance and poles and zeros are alternative and lies on negative real axis, and pole is the nearest to the origin. You look at here, pole means roots of denominator, zero means roots of numerator. Please remember, roots of numerator is called zeros because the function becomes 0, and roots of denominator, when that roots, function becomes infinity. Infinity is called pole. Pole means like a pole, it jumps infinite. That's the meaning. With that understanding, you will continue. So what is the nearest to the pole? Nearest to the origin, pole. So S equal to -1 here, then comes 0, then comes pole. So poles and zeros are interlacing. If it is LC on the j omega axis, if it is RC on the sigma axis. Then properties of RL network. For RL driving point function, the poles and zeros are alternate and lies on the negative real axis just like previous. The only difference is 0 is nearest to the origin. You see that? 0 is nearest to the origin. 0 is nearest to the origin means S equal to -1, S equal to -3, you have zeros. -2 and -4 you have poles. So poles and zeros are alternating. We call it as interlacing. Whether you hear the word called interlacing or alternating, both are same. Okay. Note. For RLC driving point impedance, the poles and zeros are complex conjugate pairs. They are all symmetric with respect to negative real axis. That means it is not on the j omega, it is not on the sigma axis. It is complex conjugate with respect to negative real axis. That means you have all the 3 components. Note, RL driving point impedance is, the properties are same as RC driving point admittance and vice versa. That means, for example, RL impedance function nearest to the origin is pole. If you see RC admittance also nearest. So when you look at RC circuit properties and RL circuit properties, very easy to remember. Whatever is valid for RC Z is valid for RL Y. That's very interesting and very easy to remember. Now I am going to synthesis. When I am going to synthesis, you must understand the properties of each one. Properties of LC immittance function. First one. If the roots of LC network only on the real axis, then the network is called purely resistive. If the roots are LC, it is purely called LC circuit. If the roots are complex, it contains RC, RL or RLC. All the roots must be interlacing. Interlacing means alternating one after the other. Fifth one. The roots nearest to the origin can be a 0 or a pole. Why it can be a 0 or a pole? Because this is valid for impedance as well as admittance. It must be a PRF function, positive real function. The network functions can have polynomial P by S, P of S, Q by S, or where P S and Q of S are positive real functions. And the ratios also can be taken as network. If the number of poles and zeros differ at most by unity, it is to avoid the break point. The breakaway point, if you avoid, what happens is the system will become unconditionally stable. Suppose if it is breaking, like we study in controls, if it is breaking, it will break and cross the j omega axis. Once it is crossing the j omega axis, it is going from negative side to positive side. If roots are going at the positive side, it becomes unstable. So to avoid the instability, it must have, the plot should be entirely on the left side, or the roots must be on the left side. That is possible only if there is no breakaway point. Breakaway point comes only when there is a consecutive poles and zeros. Suppose every pole terminated in 0, every pole is terminated in 0, finally there is one thing is missing, they can terminate by assuming that. That's why utmost unity is always good to avoid unconditional or stability to avoid. Instability we must avoid. The pole and zeros at geometry axis with complex conjugate. As I told you, pure LC, only geometry axis. RC, RL, sigma axis. RLC, complex conjugate but not on j omega axis. So this is all about LC properties. What are the different properties that we have to have before LC network? Then in synthesis you have two forms. One is called Foster form, second is called Carr form. In Foster form it is a parallel branches of series, and in a Fast form 1. Fast form 2 is serial branches of parallel. We can easily identify them and synthesize them. These are the parallel and series. One important precaution. In series branch or in parallel combination of series branch like Foster form 1, there should be no element open circuit. If any element open circuit, the total is gone. Similarly, in a parallel form, there should be no element short circuit. Short circuit means the total circuit will go. So, open circuit is not allowed in Foster form 1. Short circuit is not allowed in Foster form 2. Indirectly, in series, open circuit is not allowed. In parallel, short circuit is not allowed. Because in series, current is 0. That is very bad. In parallel, voltage is 0. Look at here. K0 and K infinity can be zeros, but not infinity. No residue is infinity. Please remember, the word residue in mathematics they call it, but in control systems and in a signals and system we call the same constant as constant of system constant. So all the system constant or sub constants, they can be 0, but they should not be infinity. Why? If they are infinity, what is happening? Short circuit is happening in parallel, not accepted. Open circuit is happening in series, not accepted. That's why the residues should never become infinity. They can be 0. Suppose if any residue is 0, that particular component is missing, but that's not short circuiting or open circuiting. This is very important precaution and statement about what do you mean by K0 and K infinity. Next, Carr form. Carr forms are two types. If we take descending order, it's called Carr form 1. If we take ascending order, it is called Carr form 2. Look at here, descending order, s square 2s plus 4, s cube 4s square plus, it is descending. Descending order is for Carr form 1. Ascending order is Carr form 2. They are not in the factors, they must be in the polynomial form. When you are trying to get the circuit for the function, they must be in polynomial form. So these are the 4 forms altogether we have. Foster forms, Fast form 1 and Fast form 2. That comes by what you call partial fractions. When you go for Carr form 1 and Carr form 2, they will be achieved from polynomials. So this is what my introduction to your synthesis procedure. We will go for the problems to really illustrate. So let's go to problems to see how to really get a circuit, and from the circuit how to achieve even the numerical values. So 3 things I am going to talk. What is the function given? Is that function satisfying properties? That's the first target. Second, what type of synthesis is possible? Is it going to be LC, RC, RL? Third, which of the 4 forms we have? So please remember, the moment a network function is given, identify which type of this network it is. Second, identify which method we should take. Then identify which elements we should take. Right? So these are the 3 questions you must see every time in every problem I am dealing with. Then only you can really understand or attack the exam. So when you're trying to crack the exam, the 3 points please. What is the function? Is it LC, RC or RL? Second, which function he is asking, which components are there? Once you decided the components, then you have to identify whether it's impedance or admittance. Once you identify impedance or admittance, you should identify what are the component values. Right, look at this first problem, question number 1. Realize LC network for the given immittance. As I said, so 10 into S square plus by S square plus 1 by S into S square plus 1. So suppose this is your function given. You can say K0 by S, K1 into S by S square plus so on. If you take the partial fractions, you will get these values. What is K0? Z of S into S, where S is equal to 0. What is K1? Z of S by S into S square plus 4, where S equal to minus 4. What is K infinity? Z of S, K infinity, and how to calculate by S, that means infinite. So if you calculate these values, you will get, after calculating, now come on, what is K0 by S? What is K0 by S? K0 by S means, is it inductor or capacitor? It is capacitor, because when in a impedance function, look at that, in a impedance function, by S means capacitor. Therefore, K0 is a capacitor, K1 is both capacitor and you will have two capacitors, capacitor and inductor there. K infinity is infinite, that's also inductor. So K0 by S, 1 by Cs, C0 is equal to 0.4. If 2.5 is by S is equal to 1 by S, and finally you have here also K0 by S, and then you are cancelling it. So how to identify this value? You have to think. So identify the value. Please understand, first and foremost thing is, he did not say whether it is impedance or admittance. How to know that? Then go back properties. The nearest to the origin is, look at here, nearest to the origin is pole. If it is the nearest to the origin is a pole, automatically the first element is capacitor. And not only that, nearest to the origin is a capacitor, automatically it is impedance, because K0 by S. So if it all depends on the nearest value, what can be the impedance function? Then when you go for this calculations and calculate those values and realize, you will have 0.4 here, 0.13 and 1.8. In a series, we got this element. So go for the components, go for the K1 and K2 and solve them, and you will get this circuit diagram. Problem 2. You know what is the problem 2 I have taken? Calculate Z of S for the circuit. Actually, the circuit is what you got in the previous. And when you go for this circuit as a previous, 0.4, 0.13, 1.8, now calculate Z of S, that means this is 1 by Cs, 1 by Cs, Ls. Calculate this value. And when you calculate this parallel combination, this is parallel combination added into this, you know what's happening, Z of S is equal to same function is going to come. So when the same function is coming, you are sure what you have done is correct. No, it is first time we are doing like that, otherwise in the exam we cannot always do it. You cannot always calculate. Every time you cannot cross check the answer, but here I am showing it as a classroom experience. You can cross check and have a joy of doing and thinking that this is correct answer is achieved. Third problem. Obtain y of s for the impedance function where f of s is 1 s into s square plus 4 by 10 into s square plus 2. What is this actually? This is exactly opposite of the previous problem. Then from there you get admittance function. Admittance means y of s, k0 by s, k1s and so on. And by solving you will get k0 is 0, k1 is this much, k infinity is this much. So these are the values you are getting for the admittance function. From admittance function what will come? Parallel combination will come. This is called, when you deal with parallel combination, we are calling it as faster form 2. Serial combination is first form 1. Parallel combination is first form 2. And once again you cross check the answer, you will get the same answer. For example, problem 4. What is problem 4? As I told you, for every problem that I have designed, I am cross checking the answer. Please cross check this answer. This is C1, for example, 1 by C1 plus 10 by 3S plus 10 by 3. So if you see really, if you calculate this parallel this one, you are getting Y. This parallel this one, you are getting Y. And if you cross check, you will get the same answer. That means whatever the answer you have, whatever the network you have taken and realized, to say that the realization has been done correct, you can cross check once or twice till you get confidence. Once you get the confidence, you don't need to cross check, you don't need to again confirmation, all this. So that is about what you call LC faster forms. So then before we go to RC synthesis, we will confirm what we have done is correct. So do it, then bring it and confirm, you will get the same answer. So this is about LC realization. Then we will go for RC realization.